This is my intermediate algebra course. Today we're going to find quadratic equations and use the discriminant to count x-intercepts. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. In my previous classes, I mentioned that we're going to move beyond quadratic equations and their graphs, but that information is so important that we're going to do a bit more today. And we're going to start by using the discriminant to find the number of x-intercepts of a parabola. But before we do that, we're going to review. This is a quadratic equation, and we learned in a previous class that if you want to find the solutions to any quadratic equation, you use the quadratic formula. And we also learned that the expression under the root is a special expression, and we give it a special name. We call it the discriminant. And the reason it's special is precisely because it's under the root. Remember, you can't have a negative number under a square root. So if the discriminant, this green part under the root, is negative, then that means this equation up here has no solutions. Now, if the green part under the root is 0, then that means this whole term will go away, and the plus or minus sign will go away with it. So this expression here will reduce to one number, and that shows us that there's only one solution to this equation. And if the green part under the root is positive, then that means this equation has two solutions, because the plus or minus sign does not go away, and you don't have a negative under the root. So this becomes a real number, two real numbers. So that was all review. If you want to take screenshots of that, you can go ahead and do that and simultaneously get the information to the right. But now we're going to use the discriminant to count the number of x-intercepts of a quadratic equation. And if you want to learn anything about the x-intercepts of a quadratic equation, you would let y equal 0. We learned that in previous classes. And the reason that you let y equal 0 to find the x-intercepts, and this is just review information, is because every point on the x-axis has a y value that is 0. We may not know the x value. We may have to do some math to find the x value. But we know the y value is 0 because those points are on the x-axis. That's just the definition of an x-intercept. The y value of those points must be 0. And if this point, turned off and crossed the y-axis, which of course it wouldn't do because it's a parabola, but on that point the x value would be 0. Because the x value of all the points on the y-axis are 0. So that's just some review, some basic review of the concept of x and y intercepts. So we want to learn information, and specifically we want to count how many x-intercepts there are on the graph of this equation. So you would let y equal 0 to find information about the x-intercepts. And when you set y equal to 0, this now becomes a special equation. It's a quadratic equation. And we're going to find, in previous classes, we found the x values that make y 0. But we also found we talked about previously that sometimes a quadratic equation can have no solutions. Sometimes it can have one solution, and sometimes it can have two solutions. So what that means in terms of x-intercepts, if you have no solutions, then the parabola is not going to even cross the x-axis. It might look like that, or it might look like this. It's not going to cross the x-axis. And again, that means that there's no x value that makes y 0. If this equation has one solution, that means there's one x value that makes y 0, so the parabola might look something like this, where it would cross the x-axis once, and the x-intercept would just happen to be the vertex. And if this equation has two solutions, then that means your parabola crosses at 2 points, at the yellow points there. So all we have to know is how many solutions there are to this equation. If we want to actually find the x values that make this equation work, that would be the equivalent to actually finding the x-intercepts. And we've done that before in previous classes. You set y equal to 0 and you solve for x. Because this is a complicated equation, it's a quadratic equation, we have to use the quadratic formula. Now that's if we're going to actually try to find the x-intercepts, but that's the thing. We're not trying to find x-intercepts. We're just using the discriminant to find the number of x-intercepts of the graph. So the discriminant, this part in the root, tells us how many solutions there would be to this equation in yellow. And if there are, 0 solutions, that means there's 0 x-intercepts. If there's 1 solution, that means there's 1 x-intercept, and so on and so forth. So all we have to do is find the discriminant, which again is that part in green under the root. And so B is -5, and A is -2, and C is 1. And then if we simplify, we get 25 plus 8, which is 33. So we don't really care exactly what the number is. We just want to know, is it negative, 0, or positive? Those are the 3 categories. So we see that this number is positive 33. So because it's positive, that means that that equation in yellow up there has 2 solutions. That means that there are 2 x values that you can plug in to make y 0. So there are 2 solutions to the equation, and there are 2 x-intercepts. 2 x-intercepts of this equation here in blue, if you graph that equation. And that's the problem. That's all we have to do. We just have to figure out how many x-intercepts there are. So if you were to graph this equation, it would look something like this. You can see that there are 2 x-intercepts because the parabola is crossing the x-axis at two points there. Now, all this information is summarized here. If the discriminant in blue over here is positive, then you have 2 x-intercepts. And if it's equal to 0, then you have 1 x-intercept. And if it's negative, then you have no x-intercepts. And remember, this is just an inequality symbol. Pac-Man wants to eat the bigger number. So that means this number is bigger, the discriminant is bigger than 0, which means that it's positive. And over here, it's less than 0, which means it's negative, and there are no x-intercepts. So again, if you want to get a close-up view of that, you can take a screenshot of that information. And now ready to go on to the next problem here. Now again, we're trying to count how many x-intercepts the graph of this equation has. And if you want to learn anything about the x-intercepts, you have to set y to 0. And if then we just find, again, we're not looking for the x-intercepts. We're just trying to figure out how many there are. And we can use the discriminant of this equation here to do that. So now we just plug in b, which is 12, and a, which is 1, and c, which is 36. 12 squared is 144, and then we get 144 there, and we see the discriminant is 0. So what that means is there's 1 solution to that equation up there in yellow. There's 1 x value that if you plug it into that equation up there in yellow, it makes y 0. So that means that there's 1 x-intercept. And that's the answer. If there's 1 solution to that equation, if there's 1 x value that makes y 0, then that means there's 1 x-intercept of this equation if you graph this equation up here. So if you graph that equation again in blue up there, then you get something that looks like this. Sorry, my computer's going kind of slow. You can see that there's only 1 x-intercept. And that's right here at the red point where it crosses the x-axis. Okay, so let's do one more of these problems. again, if you want to learn anything about the x-intercepts of the graph of this equation, you let y equal 0, and then you find the discriminant of that resulting equation with y equal to 0, the discriminant of this equation. And we have 4 squared minus 4 times a times c. B is 4. 4 squared is 16. And then we have, looks like, negative 24. So the discriminant is negative 8. Now again, it doesn't matter what the number is. We just want to know, is it negative, 0, or positive? This is negative, so that means there are no solutions to this equation up here. There's no x values that you can plug in to make y 0. So no solutions to that equation. But if there are no solutions to that equation, there's no x values that make y 0, then that means there's no x-intercepts of this corresponding, of the graph of this equation in blue. And that's the final answer. All right, and if you graph, again, that equation, this equation up here in blue, then you see that the graph doesn't cross the x-axis in purple here. So there's no x-intercepts. Okay, it's time for you to try. Again, you're trying to find the number of x-intercepts. It's either going to be 0, 1, or 2, and you're going to use the discriminant, this expression in green over here, to figure that out. So try number 4, and when you come back, we'll do it together. All right, we're back. To learn anything about the x-intercepts of the graph of an equation, you let y equal 0, and then you just find the discriminant of that resulting equation, and b is negative 10, and a is 25, and c is 1. Negative 10 squared is 100, and 4 times 25 is 100, times 1 is 100, so the discriminant is 0. So what that means is there's one solution to this equation. The discriminant tells us there's one solution. And if that means there's one x value that will make y 0. But if there's one x value that will make y 0, that means there's one x-intercept. And that's really the final information that we're looking for. We're trying to figure out how many x-intercepts there are. And that's really the final information that we're looking for, how many x-intercepts there are. And if you graph that equation up there, this equation at the upper left in blue, if you graph that, it looks something like this, and you can see that there's only one x-intercept at that red dot. So if you got that answer, good job. Okay, for number 5, you can use a calculator. The numbers are going to get kind of big. So try number 5, and when you come back, we'll do it together. All right, we're back. So again, if you want to find any information about the x-intercepts of the graph of an equation, then you set y to 0, and that is now a special equation. It's called a quadratic equation, and you want to find the discriminant so you can count the number of x-intercepts of this corresponding equation here. So b is negative 33, and a is 10, and c is negative 7. And now 33 squared is 1089. And multiplying all those numbers, you would get 280. So add those numbers together, and you get 1,369. So we don't really care about the actual number. We just want to know, is it negative, 0, or positive? And you can see that this discriminant down here is positive. So that means that there are two solutions to the equation in yellow. And that means there's two x values that make y 0. If there's two x values that make y 0, then that means there's two x-intercepts of this blue graph up here. Two places where the graph crosses the x-axis. And that's the answer, two x-intercepts. And if you graph that equation, it would look something like this. You can see there are two places where the parabola crosses the x-axis. So if you got that answer, good job. Okay, let's do one more of these. Try number 6. Find the number of x-intercepts, and when you come back, we'll do it together. All right, we're back. Whenever you're trying to find information about the x-intercepts, you always want to let y be 0 and solve for x. But we don't really have to solve for x in this case because we're just looking for the number of x-intercepts. We're not actually trying to find the x-intercepts. We already found the x-intercepts in previous classes. So b is -3, and a is -1, and c is -3. And if we simplify, we get 9 minus 12, which is -3. So the discriminant is negative, and that means that there is no solution to this equation here. This equation has no solutions. There's no x values that you can plug in to make y 0. So that means that there's no x-intercepts. And that is the final answer. So if you were to graph that equation, it would look something like this. You can see that the graph doesn't pass through the x-axis, the purple part here. So there should be no x-intercepts. There's no x value that you can plug in that would make y 0. Okay, so now we're going to move on to the next thing we're going to do today, which is writing quadratic equations given their graphs. Now, in previous classes, we were given a quadratic equation and we were asked to draw the graph. But now we're going in the opposite direction. Now we're given a graph and we're asked to write the equation. Now notice here it says it's easiest to use vertex form. In all these problems we're going to be using vertex form. We're not going to be using standard form or intercept form. And you can kind of see why that is. I mean, we have the vertex. We can see the vertex just by looking at this graph here. And so I'm going to label the vertex V, and what you'll find is that we don't have to use both of these points. We just have to use one of them. So I'm going to choose this point over here. But if you choose this point, you get the same answer. And then I'm going to label the vertex. The vertex is 2, 4. And the other point is 0, 1. And then we're going to use, like I said, the general vertex form of a quadratic equation. And what you'll notice is that, you know, we have the vertex, so we have h and k. We have almost everything we need to just go ahead and write the equation of this parabola here. The only thing that we don't have is a. We need to find that constant. So what we're going to do is we're going to use this point over here to find that constant. We're going to rewrite this equation, but we're going to plug in the y value of our point over here for y, the x value of our point over here for x, and then, of course, h is just the x value of the vertex, that's 2. And k is the y value of the vertex. So I'm going to color that. And now all we have to do is solve for a. And, you know, we just have to follow order of operations. And remember, we know order of operations from our acronym PEMDAS. PEMDAS tells us to do the calculations in parentheses first. So that would be 0 minus 2, which is -2. Then it tells us to do the exponents next. So -2 squared would be +4. And then, it's traditional to write the coefficient to the left of the letter, so I'm just going to move that over. It looks more familiar. Subtract 4 from both sides, and we don't really have to do this math because this is just pre-algebra stuff, but I'm going to, this is a good opportunity to go ahead and review, just some basic algebra. Most teachers would not show these steps, but, I'm just going to go ahead and do it. So now we found A. And by the way, because this whole step is just finding A, I'm going to go ahead and label this as step 1, which is to simply find A. And then we just have to write the equation. This is the last step. Write the equation of the parabola that we were given, this parabola here. So we use general form, and all we have to do is plug in A, which we just found, and H and K, which we were given in the first place. So A is -3/4, and H was 2, and K was 4. I'm going to move this down a little bit. So again, we were given the vertex. We were given 2 and 4, but we just needed to find -3/4, which is A. Okay, so let's try another one of these problems. I'm going to label the vertex V, and I'm going to use this point over here. And step number 1 is to find that constant A value. And I'm going to rewrite the coordinates of the vertex, which are -3, 3. And the point that I'm going to use looks like -2, 5. And then we're going to use general vertex form because that's just the easiest form to use. For y, I'm going to plug in the y value of our point. For x, I'm going to plug in the x value of our point. And h is the x value of the vertex. And k is the y value of the vertex. And I'm going to color those. And then we're going to simplify. That's a double negative, so it becomes -2 plus 3 squared. And -2 plus 3 is 1. I have to stop making my A look like a 9. And 1 squared is 1. And A times 1 is A. And subtract 3 from both sides, and we get A is equal to 2. So now we just move on to the second step, which is to find the equation. That was the whole point of the problem. The equation of that parabola on the graph. And so all we have to do is plug in the A value that we just found and H and K. And by the way, you don't have to keep rewriting the general form. A was 2, and the x value of the vertex is -3, and the y value of the vertex is +3 in green. Now, we don't want to leave our final answer with a double negative. There's no reason to leave a double negative, so we just simplify that to +3. Remember, if you're given an equation in vertex form, as you see here, then the x value of the vertex is always the opposite sign, and the y value always stays the same, so that's why we have -3, 3. It's -3 for the x value of the vertex, but then when you plug it into the equation, it's positive, so the sign of the x value of the vertex always changes, but the sign of the y value of the vertex does not change. That's just review. So you can take a screenshot of those two problems. You're going to do the next two problems. So if you want to use these problems, take a screenshot. And I want you to try number 9. And when you come back, we'll do it together. All right, so step number 1 is to find the constant A. And I'm going to label the vertex and the point that I'm going to use. Now, if you use this point, that's okay. You're still going to get the same answer, or at least you should if you do the math right. So the vertex you see is 1, 0. And the point that I'm using is 0, -4. And we're going to use the general vertex form. For y, we're going to plug in the y value of our point. For x, we're going to plug in the x value of our point. H is the x value of the vertex, and k is the y value of the vertex, and I'm going to color those in. And now we just solve for a. We find a. I don't have to write the plus 0. -1 squared is 1, and 1 times a is a, and so a is -4. So now we just have to find the equation of this parabola here. And we just have to plug in a and h and k to the general form, the general vertex form, that is. So we just found that a is -4, and the vertex we were given, it's 1, 0, so we just plug in 1 and 0. But we don't really need that plus 0 there, so we're just going to get rid of that, and that's our final answer. So if you got either of these two answers, that's good, but you can get rid of that 0. So I want you to try number 10 now, and when you come back, we'll do it together. All right, we're back. So I'm going to label the vertex, and I'm actually going to use this point up here. If you used a different point, that's okay. If you do the math correctly, you should get the same answer. So first step, of course, is to find a, and the coordinates of the vertex are -2, -5, it looks like, and the other point that I'm using is 2, 3. And we're going to use the general vertex form. For y, we're going to plug in the y value of our point. For x, we're going to plug in the x value of our point. H is the x value of the vertex, and k is the y value of the vertex. And I'm going to color those. Now we just have to solve for a. -2 minus -2 is 2 plus 2, and 2 plus 2 is 4, and 4 squared is 16, and it's traditional to write the coefficient to the left of the letter, add 5 to both sides. Again, you don't have to show all these steps because this is just, pre-algebra stuff. But I'm just doing this to give you a chance to have a little review of the basic algebra. So now we know that a is 1/2. So now that we know a is 1/2, we can write the equation of the parabola that was graphed up there, which is the whole point of the problem. And all we have to do is just plug in the a value that we just found and h and k, and we were given the vertex. We found a is 1/2. The vertex is -2, -5, so we plug in -2 for the x value of the vertex and -5 for the y value of the vertex. But we don't want to leave a double negative in that equation, so we're just going to simplify it to x plus 2. And there you go. So if you got that answer, good job. All right, on to the next problem. We're now going to write quadratic equations given information about their graphs. These problems are exactly the same problems that we just did, no difference whatsoever. Except instead of somebody giving us a graph and then asking us to write the equation, they're giving us characteristics of the graph, points on the graph, that is. You see. So, but we're still going to be using the vertex and a point, so it's the exact same type of problem. And you might think, well, why are you giving the same exact problem? Well, sometimes you can just change one little detail of a problem and students will get completely lost. So it's important for you to see variety And even though this is the exact same problem, you know, it's good to for your understanding, so that you know how to think. When you see a problem, you can actually think about what it's asking you rather than just, you know, use rote mathematics. Now, notice it says, assume that the corresponding parabola is open up or down. You can actually have a parabola that opens to the left or sometimes to the right with these characteristics. So we're assuming that our parabola is open up or down. But like I said, it's just the same type of problem. First step is going to be to find that a value. And we, well, let me go ahead and write the vertex again. I'm going to rewrite these coordinates so I don't get confused about which numbers go where. And we're going to use general vertex form. So I'm going to plug in the y value of our point for y, the x value of our point for x, h is the x value of the vertex, and k is the y value of the vertex, and I'm going to color those. And now we just solve for a. That's a double negative, so we have 1 plus 4 squared. And 1 plus 4 is 5. And 5 squared is 25. And put the 25 in front of the a. And subtract 7 from both sides. Divide both sides by 25, and we get negative 8 over 25 is equal to a. So now we have a, and the second step is just to find the equation that has those characteristics that were given to us. So all we have to do is plug in a and the vertex coordinates, and we're done. So a we found is negative 8 over 25, and the x value of the vertex is negative 4, and the y value of the vertex is 7. And so we don't want to leave that as a double negative though, so it would be x plus 4. And there you go. So as you can see, that was pretty much the exact same type of problem that we did before. So I want you to try number 12, and when you come back, we'll do it together. All right, we're back. So step 1 is to find a, and I'm going to go ahead and rewrite the coordinates of the vertex and the other point. So the y value, for y we're going to plug in the y value of our point, and for x we're going to plug in the x value of our point, and h is the x value of the vertex, and k is the y value of the vertex, and I'm going to color those. And now we just have to solve for a. 3 squared is 9. And you don't have to do this step. In fact, you don't have to do a lot of these steps to find the answer, but I'm just going to put that 9 in front of the a. That's traditional. So we see that a is equal to 1. Now we just have to find the equation, or write the equation, however you want to say it. So we plug in a, and we plug in h and k. So a is 1, which means we don't really even have to write anything. And the x value of the vertex is 2, and the y value of the vertex is negative 3. So if you got that answer, good job. All right, so again, those problems were exactly the same problems that we did before with the graphs. These next problems are actually exactly the same also. The only difference is they're giving us the second point in a different form. They're not telling us the actual coordinates. They're just telling us that one point is an x-intercept. So how do we do this? Well, step 1 is to find a, of course. And they're giving us the vertex 1, 4. But now we have to interpret this information as a point. remember, the y value of any x-intercept is always 0. So we know that the x value of the point is -6 and the y value is 0. Okay, so when you see this information, you don't immediately understand it as an ordered pair, as a point, but it is a point. But they only give you one number because it's assumed that the y value has to be 0 if it's an x-intercept. If it's an x-intercept, then that's just, that's the definition of an x-intercept. Y has to be 0 on that point. So now we've got the vertex and our point. And for y, we're going to plug in the y value of our point, and for x, we're going to plug in the x value of our point, and h is the x value of the vertex, and k is the y value of the vertex, and I'm going to color those in. And then we just have to solve for a. -6 minus 1 is -7, and -7 squared is +49. And, we really don't have to do this, but it just makes it look a lot more familiar if we put the coefficient to the left of a. So now we subtract 4 from both sides, divide both sides by 49, and we get -4/49 is equal to a. Now we want to find the equation of the parabola that has these characteristics up here. That's the whole point of the problem. And so we just need to plug in a and h and k. So we found that a is -4/49. And the h is 1, that's the x value of the vertex, and k is 4, the y value of the vertex. So there you go. So as you can see, it's not too bad there. Now, I want you to understand that before you try number 14, 4 is not an x-intercept, it's a y-intercept. If 4 was an x-intercept, then the corresponding point would be 4, 0. That's not correct. Okay, this is a y-intercept, not an x-intercept. So the point over here, P, is going to be 0, 4. Be aware of that. So I want you to try number 14, and when you come back, we'll do it together. All right, we're back. So step number 1, as usual, is to find that constant, which we call a. And I'm going to just rewrite the coordinates of the vertex and the point so we don't get confused. So again, that's 0, 4. It's not 4, 0. Y-intercepts are different than x-intercepts. So now we're going to use the general vertex form. And for y, we're going to plug in the y value of the point. For x, we're going to plug in the x value of the point. H is the x value of the vertex, and k is the y value of the vertex, and I'm going to color those. Now we just have to simplify and solve for a. So 0 minus -6, that's a double negative, so that becomes 0 plus 6. And 0 plus 6, of course, is 6. And 6 squared is 36. And then we subtract 2 from both sides, divide both sides by 36, and a reduces to 1/18. I reduced in my head there. That's all just basic math. You should know that. And if you need review with reducing, you go back to my arithmetic course. Now we're going to find the equation that has the characteristics that we were given at the beginning of the problem. So all we have to do is just plug in a and the x value of the vertex and the y value of the vertex. So we just found a is 1/18. The x value of the vertex is -6, and the y value of the vertex is 2. So then we have x plus 6 because it's a double negative. Just simplify that. And there you go, that's the final answer. So if you got that answer, good job. Okay, on to number 15. So in this problem, we're given a point on the parabola, the vertex, But this other information, this is not a point. Okay, so we actually only have one point that's actually on the graph. So in this problem, we can't find A directly. In this problem, we have to first find P. Now you might be thinking, what in the world is P? Well, remember P, we found that value. P is equal to 1 over 4a. P represents the distance from the vertex to the directrix. It also represents the distance from the vertex to the focus. And if we can find P, then we can use P to find A using this equation here. We learned that equation in previous classes. In fact, I'm going to give you that here. This is review information. You can take a screenshot of that if you want to. That's where we got that. We're going to use this information in the next 5-6 problems. So we first need to find P, and then we're going to use that to find A. Now, there's a couple different ways you can do this. I'm going to first show you what I call the conceptual method, which is really just picturing the graph in your head. If you understand the relationship between the directrix and the vertex and how that, how P, or what P means in relation to those numbers, you can really do this in your head. You don't have to really show any of this, but to give you an idea what's going on here, I'm going to draw the graph, and the vertex we know is 2, 7. That would be maybe about here. And the directrix is y equals 5, which I'll say maybe is about here. This is just a rough graph. It doesn't need to be perfect. And remember that the parabola is always going away from the directrix and towards the focus. Now, we don't really care about the focus in this graph. We don't have to draw that. But the parabola is going something like this. And you don't need to draw the parabola either. I'm just, we're just showing you that so you have an understanding of what's going on here. So P is this distance from the vertex to the directrix. And by the way, the vertex is 2, 7. So the reason I call this the conceptual method for finding P is that we can see what P is just by picturing this information in our heads. This line is y equals 5, and the purple point here has a y value of 7. So you're going up from 5 to 7 to get, that distance. So what is the distance between 5 and 7? If you're going straight up, that would just be 2. So P is equal to 2. And if the parabola is going up, it's going to be positive 2. If it were going down, it would be negative 2. So that's the conceptual method. Again, it's just kind of common sense. We're just going up from 5 to 7. So that when they give us this directrix and the vertex, it's really easy to find P. But I just want you to be aware that, if you didn't understand the graphing method for finding P, you can also use an algebraic method. And the algebraic method says that where you can use the equation of the directrix. We know the equation of the directrix is y is equal to the y value of the vertex minus P. And I'm going to color everything as we go along here. Now, every point on this green line, the directrix, has a y value of 5. So what that means is we can just plug in 5 for y. I know that seems kind of strange, but the algebraic method is kind of strange in my opinion, but so I prefer the conceptual method. Now the y value of the vertex, we were given that number, that would just be 7, and now we can use this equation to solve for P. And you don't really have to color all this stuff, but if we solve for P, we subtract 7 from both sides, and we get P is equal to, or negative P is equal to negative 2. Divide both sides by negative 1, and we see P is equal to 2. So we got the same answer that we did with the conceptual method. So, you're probably saying, well, I don't really get it. Who cares about P? Why are we trying to find P? Well, again, if we find P, we can use that to find A. which is what we're really looking for, because we're trying to write the equation that has these characteristics, the equation of the parabola that has those characteristics. So now that we have p, we know that p is equal to 1 over 4a, and p was, what was it? It was 2. So we just plug in 2 for p, and we can write 2 as 2 over 1. Now we can use the fundamental principle of fractions to multiply both sides of this fraction by 4a. 4a times 2 is 8a. 4a times 1 is 4a. By the way, what we're doing here is just solving an equation with a fraction. You can go back to my beginning algebra course, or I might teach a class. I think I might teach a class on equations with fractions in this course just as review. You may have already done that. And so now we have two fractions that are equal to each other and the denominators are the same. So if the two fractions are equal and the denominators are the same, then just common sense tells us that the numerators must be equal. And then we can divide both sides by 8, and we have a is equal to 1 over 8. So we found a. So all we have to do now is just write the equation. So because we have a and they gave us the vertex, we just plug everything in just like we did in the previous problems. So a is equal to 1/8, and the x value of the vertex they gave us up there is 2, and the y value of the vertex is 7. So that is the final answer. So that took a lot longer than it really needed to take, just because I was showing, both these methods, and like I said, you really don't have to do that stuff at all. You don't have to write anything down. You just have to, find p in your head, which should be pretty easy. Okay, so try number 16, and when you come back, we'll do it together. All right, we're back. So first step here is to find p, and you don't have to use both these methods, but I'm just going to show you the conceptual method, which is really just graphing in your head. And I'm also going to show you the algebraic method. So we're just going to draw a rough graph, doesn't have to be perfect, and we want to draw the vertex, which would be maybe about there, and the directrix is maybe about here. Again, these proportions don't have to be exact. And so what this means is that our parabola should be opening down, because it has to open away from the directrix. That's the vertex. And so what we're looking for is the distance from the vertex to the directrix, which we call p. And the green line is y equals -4, so then you can just go down from -4 to -5, and obviously we just went down 1 unit. So p is equal to 1. But hold on for a second, the parabola is going down, so p is actually going to be -1. Remember, p is always negative if the parabola is going down, and it's always positive if the parabola is going up. So that was the conceptual method, and you can use either method. You don't have to watch me show you both methods. You can skip forward. But I'm going to show you the algebraic method also. So we have y. The equation of the directrix is y is equal to the y value of the vertex minus p. And then we just plug in -4 for y, because y is always -4 for every point on the directrix, and the y value of the vertex is -5. And I'm going to color all that stuff. And then we just solve the equation, add 5 to both sides, and we get -p is equal to 1, divide both sides by -1, and we see that p is equal to -1. So those are the two methods you can use to find p. And now we want to find a. So go up to step 2 here. And you can put a divider here if you run out of room. So to find A, we know that P is equal to 1 over 4A. We plug in P, which we found is -1. We can write -1 as -1 over 1. Then I'm going to multiply both sides of this fraction by 4A, so we can get a common denominator. And because the fractions are equal, this equation tells us the fractions are equal. And also I wrote this fraction so that we have the denominators are equal. Just by common sense, we know that the numerators must be equal. So now we divide both sides by -4, and we get A is equal to -1/4. So now that we have A, we can just write the equation. And of course, we always use general vertex form. We just plug in A, H, and K. A is -1/4. And H is -2. And K is -5. Now remember, you don't want to keep a double negative in your final equation. That's just unnecessary. So you can change it to a positive. And there we go. So if you got that equation, good job. Okay, let's go on to the next problem here. So now, again, we're given a point on the parabola here, but this information, this point here, is not actually on the parabola. This is the focus. So, you know, this problem is going to be much like the previous two problems that we did. And, you know, we're just going to, the first step is going to be to find P, same as the previous problem. And again, there's the conceptual method, which is just picturing the graph in your head. And there's the algebraic method, but first let's do the conceptual method. So 8, -3, that would be maybe here, roughly. And the focus, I'm going to draw in pink, that's 8, 0, that would be about here. And so, you know, that means that the directrix has to be down here. The parabola is always going to open towards the focus. So it might look something like that. And so here we have 8, 0, and for the vertex we have 8, -3. And the value we're looking for is P, and again, we can see what P is just by, you know, looking at these coordinates. You know, P is always going straight up, so the x value doesn't change, but we're going from y equals -3 to y equals 0, so that's just 3 units up. So P must be equal to 3. Now it's positive 3 because the parabola is going up. It'd be -3 if the parabola were going down. So now let's do the algebraic method, and again, you don't have to, if you don't like the algebraic method, or if you don't like the graphing method, you can just skip by whichever one you don't want to use. So now, you know, we're going to be using some different information. In the previous problems, we used this information here because we were given the equation of the directrix. Now we're given the focus, so we're going to use this information here. And I'm going to label the focus with an F, but so we have F, the coordinates of the focus, and remember the x value of the focus is always the x value of the vertex, and the y value of the focus is always the y value of the vertex plus P, not minus P, plus P. And so we know what the coordinates of the focus are. It's 8, 0. Now, as you can see here, this information must be 0. So we can set those expressions equal to each other and we can do that or we can use that to solve for p. Now the y value of the vertex is -3. We can see it up there. So we can plug in -3 and maybe color those to help us understand where they're coming from. And then we are again looking for p, and we just solve that equation and we get p is equal to +3. So that was the algebraic method, and now let's use p to find a. And we can put a divider, and of course we're going to use that same equation, p is equal to 1/4a. Now p we found is 3, and I can write 3 as 3/1. And I'm going to multiply both sides of this fraction by 4a. So 3 times 4a is 12a, 1 times 4a is 4a. And now these fractions are equal to each other. We know that because it says it. We also know that the denominators are equal, so common sense would tell us that the numerators must be equal. Then we can divide both sides by 12, and we see that a is equal to 1/12. So now we can just find the equation, which is the whole point of the problem. We want to find the equation that has these characteristics, or the equation of the parabola that has those characteristics. So all we have to do is plug in the constant a and the vertex coordinates h and k. So we just found that a is 1/12, and they told us that the vertex is 8, and that the x value of the vertex is 8, and the y value is -3. So that is the final answer. Now I want you to try 18. That's going to be a similar problem, and when you come back, we'll do it together. All right, we're back. So first step is to find p, and you don't have to use both of these methods, but I'm going to show you the conceptual and algebraic methods. And remember, the conceptual method is just really graphing. And so we're going to draw a rough graph, and the vertex is 1, -2, so I'll put that maybe about here, and the focus is 1, -3, so I'll put that about here. And remember, graphs always open towards the focus and away from the directrix. The directrix would actually be here, but we don't need to draw it. Now the distance from the vertex to the focus, like I said, that's p. We call that p. And the focus is 1, -3, and the vertex is 1, -2. So we can see, just by looking at these coordinates, the distance from -2 to -3 going straight down is just 1. So p is equal to 1. But because the parabola is going down, it's actually going to be -1. So that was the conceptual method for finding p. Now let's use the algebraic method. So we know that the x value of the vertex is the x value of the focus, and the y value of the focus is the y value of the vertex plus p. And I always label the focus with that color. And we know that the focus is 1, -3. We were given that information, so we know it must be 1, -3. And so that gives us an algebraic equation. We know that Vy plus P must be equal to -3, because the y value of the focus must be the sum of the y value of the vertex and P. So I'm going to color these real quick, if that helps. So now we just plug in the y value of the vertex, because we were given the y value of the vertex, that's -2. and then we can solve for p. So add 2 to both sides, and we get p is equal to -1. So you can see we got the same answer. All right, on to step 2. Now that we have p, we're going to use p to find a. So p is equal to 1 over 4a, and we found p is -1. And I can write -1 as -1 over 1, and then I can multiply both sides of this fraction by 4a to get -4a over 4a. Now we have two fractions that are equal, and the denominators are the same. So that means, just by common sense, the numerators must be equal. Then we divide both sides by -4, and we get -1/4. So now that we found a, we can write the answer to this problem. The whole point of the problem is to find the equation that has these characteristics, the equation of the parabola. So all we have to do is plug in a and h and k. So a we found is -1/4, and the x value of the vertex is 1, and the y value of the vertex is -2. So if you got that answer, good job. Now we just have 2 more problems, it looks like. Now this is the first problem where we're not given a point on the parabola. We're given the directrix and the focus. Remember, the focus is not on the parabola. Also, this is the first problem where we're not given the vertex. The first problem where we have to find an equation where we're not given the vertex. So we have to find the vertex, and we also have to find p so that we can use it to find a. So step number 1, we're going to find p, and we're going to draw a rough graph, and the focus is going to be 3, 2.5, which is maybe about there, and the directrix is y equals -2. And by the way, this is the conceptual method again. I'm going to show you 2 methods. Conceptual and algebraic. And again, the conceptual method for these problems is just really graphing. And, you know, a parabola, just for reference, our parabola is going to be going something like this. It has to go away from the directrix line and towards the focus. And remember, you know, the distance from the focus to the vertex is p, and the distance from the vertex to the directrix is also p. Those don't exactly look the same, but you get the point. So you know, it'd be nice if we had the coordinates of the vertex, then we could find, you know, p pretty easily. But, you know, we don't have the vertex, so how do we do this? Well, we know that we can find the distance from the focus all the way to the directrix. And, you know, we can just do that conceptually. This is y equals -2, and this is y equals 2.5. So you can go up 2 units, up 2 units to get to the y-axis. And then you go from the y-axis 2.5 units to get to the focus. So 2 units plus 2.5 units is 4.5. And be aware that the vertex is not actually on the x-axis. It's a little bit above, and you know we don't really know that yet. But so that distance is 4.5, and then we just divide it by 2, and we get p is equal to 2.25. But that was all conceptual. We did that in our head, and a lot of students may get kind of confused by that. So I'm going to show you an algebraic method, and the algebraic method might look, a little convoluted, but again, that's just because I'm trying to show you something on paper. So this method tells us that 2 times p, which again is this whole distance here, and maybe I should label that. I'll label that orange. That whole distance there, which is 2 times is double p, this double length of p, that's equal to the y value of the focus minus the any y value of the directrix. And I have to use all this crazy notation because again it's kind of hard to show all this, but p, well, we don't know p yet, but we know the y value of the focus is 2.5, so I'm going to write that in, and we know of course that all the y values on the directrix are -2, so we have minus -2, and so 2p is equal to 2.5 plus 2, which is equal to 4.5, but that's not p, that's double p, so we have to divide both sides by 2, and we get p is equal to 2.25. So again, I know that seemed really convoluted, but understand that you don't have to write all that. You can use the conceptual method. If you understand the relationship between the vertex and the focus and the directrix, you don't really need to do all this complicated algebra. So those are 2 methods to find p, and remember, this vertex has to be going up, and maybe I should draw that because it's going away from the directrix, or this parabola is going up. It's going away from the directrix, so p is going to be positive. Okay, so now we go on to step 2, which is to find, of course, a. Now that we have p, we can find a. So p is equal to 1 over 4a. We can plug in 2.25 for p. And 2.25 can be written as 2.25 over 1. Then I'm going to multiply both sides of this fraction by 4a. Now 4a times 2.25 is 9a. So a lot of students may have a little trouble with that. That's just basic arithmetic though. 2.25 times 4 is 9. So we get 9a over 4a is equal to 1 over 4a. These fractions are equal and the denominators are the same, so obviously the numerators have to be equal, and divide both sides by 9, and we see a is equal to 1/9. So now we have a, but we have to find the vertex. We have to know the vertex and a to plug in, or to find the equation, because remember we're going to use vertex form. We need a and h and k. We found a, but we don't have h and k in this problem. This is one of the first problems where we were not given the coordinates of the vertex. And in fact, I'm going to write the coordinates of the vertex as vx, vy, because we don't know what they are. And so what we can do here is use the coordinates of the vertex, but first let me label this step. Or we're going to use the coordinates of the focus. We know that the focus, the x value of the focus has to be the x value of the vertex, and the y value of the focus has to be the y value of the vertex plus p. But we know what the focus is. We know the focus is 3, 2.5. And so because we found p, we're going to use that to find the y value of the vertex. But let me color this stuff. we're going to equate these, and we're also going to equate these. So obviously we have the x value of the vertex, but the y value of the vertex plus p must be equal to 2.5. Or excuse me, 2.25. Actually, no, I'm sorry, that's correct. So the y value of the vertex is what we're looking for, and we're going to add p, which is 2.25. And I'm going to color these. Subtract 2.25 from both sides, and the y value of the vertex, you can see, is 0.25. And you can also write it as 1/4. And you know, if we section this off here, we can see that Vx must be equal to 3. That's pretty easy. There's not really a lot of work to do on that. So that means that the coordinates of the vertex are 3 and 1/4. And so now that we have the vertex, all we have to do is write the equation. So step 4 is to write the equation. Okay, so again, we're using general vertex form. And we know A is 1/9, if you look up there. And the x value of the vertex is 3, if you look up in the purple there. And the y value of the vertex is 1/4. So that is the answer. So I want you to try number 20, and when you come back, we'll do it together. All right, we're back. So first step, just like the previous problems, is to find p. And we can use the conceptual method or the algebraic method. Again, the conceptual method is just picturing the graph in your head. So we have a directrix at y equals 1. I'm going to put y equals 1 all the way up here. And we have the focus, which is -3 1/2, which would be about, actually I can't put 1 up there, I guess. Let's see here, let me move this over. So if that's y equals 1, then the focus would be, you know, somewhere around here. It's not exact, but you get the point. So the focus is -3 1/2. And, you know, the vertex, we know the vertex has to be right in between. But we don't know the coordinates of the vertex. And we know that the parabola has to open down because it always opens away from the directrix and towards the focus. We don't really need to draw the parabola, though. Okay, so now P is going to be this distance, but it's also going to be this distance. And you know, we can just look at the coordinates here. So the y value of the focus is 1/2, and this green line is at 1. So the distance from 1/2 to 1 would just be 1/2. This yellow distance from the pink point all the way to the green, that distance is 1/2. So if you divide that in 2, because again P is 1/2 of that distance, then 1/2 divided by 2 is 1/4. So that's the conceptual method. But again, a lot of students wouldn't like the conceptual method because you're not actually showing anything except the graph. So the algebraic method, we're going to find this distance here, the total distance, which is hard to show. It's kind of cramped in there. Let me move the P over. So this whole distance here in orange, we're going to find here. I don't know if that's helping you or just making things more complicated. But that's double P, 2 times P, which is equal to the y value of the focus minus the y values of the points on the directrix. So now we just plug in. The y value of the focus is 1/2, and the y values on the directrix are 1. So 2p is equal to 1/2 minus 1, which is negative 1/2. Divide both sides by 2, and we see p is equal to negative 1/4. And I forgot to mention that this p value should be negative because the parabola is going down. It's easy to forget that using the conceptual method. So let me color these. Okay, so we found P. Now we're going to use P to find A. And we know that P is equal to 1 over 4A. And P is negative 1/4. So you can kind of see just by looking at this equation what A is going to be. It's obviously going to be negative 1. But what we're going to do is we're going to multiply both sides of this fraction by A to get negative A over 4A is equal to 1 over 4A. So again, all I did is multiply this fraction, both sides of this fraction by A. And so because the denominators are the same, and I should probably put this negative up like that, the denominators are the same and the fractions are equal, so that means just by common sense that the numerators must be equal. So I'm going to draw an arrow because we're out of room. So negative A is equal to 1. Divide both sides by negative 1 and we get A is equal to negative 1. So at this point we're going to find the vertex. And to find the vertex, we're going to use our knowledge of the focus. We know that the focus must be related to the vertex, like so, and we have the coordinates of the focus. They are negative 3 and 1/2. And so we know the 1/2 must be equal to all of this, so the y value of the vertex plus p must be equal to 1/2, and we know p is negative 1/4, so then we can add 1/4 to both sides, and we see that the y value of the vertex is equal to 3/4. Now adding 1/2 and 1/4, that's just basic arithmetic. I can't really show you how to do that in this class. We don't have time. You can go back to my arithmetic course if you forgot how to do that. But if you did forget how to do that, then I'd start to get kind of worried, because this is intermediate algebra. You're expected to know basic arithmetic. Okay, so let me color those. So now we have the y value of the vertex. And of course, the x value of the vertex will just be equal to negative 3. So the coordinates of the vertex are negative 3 and 3/4. All right, so now we need to write the equation that we're looking for that has the characteristics of the parabola, or the equation of the parabola we were given. So we're going to find the equation, and of course all we have to do is plug in A, which we found, along with H and K, which we just found. So A is equal to negative 1 and H is negative 3. and k is 3/4. Now we're not going to leave it as a double negative though, so we have negative x plus 3 squared plus 3/4. And there you go. So that was the class today. If you'd like to take screenshots of all the work that we did to help you with your homework or to study for tests, you can go ahead and do that now. Here's screenshot number 1 and screenshot number 2 and number 3 and number 4 and number 5 and number 6 and number 7 and number 8 and number 9 and number 10. But don't go before you get your homework. Let's take a look at the homework. Here's the homework. Get a screenshot of the first 2 pages. And these are the last 3 problems, along with the answers to the homework. And please show your work. If you just write the answer and don't show anything, all that proves is that you didn't really do the homework at all. Also, remember your work has to have 4 characteristics. It has to be complete, correct, neat, and in chronological order in your binder. And remember, if you don't do the homework, it's 100% guarantee you're going to learn absolutely nothing in this entire course. So get that homework done, and I'll look forward to seeing you in the next class.